Raspberry Pis never seem to be in stock, and when they are, they sell out quickly, you're limited by the quantity you can purchase, it's a real mess. So what alternatives are out there? One of the latest single board computers to hit the market is the Orange Pi 5. It has some modern hardware making it one of the most powerful single board computer solutions available today, and the best part, it's actually available today. Like literally you can go buy one right now. In this video, I'm going to give a quick overview of the Orange Pi 5, list some of the pros and cons, and then configure it to boot from an M.2 SSD. You heard that correct. One of the coolest things about the Orange Pi 5 is that it has an M.2 slot built right onto the bottom of the board. Now, I've already gone through the learning curve and done all of the hard work in order to make your life easier, so let's dig into the Orange Pi 5. Did you know that only 25% of the people who watch these videos are actually subscribers? If you enjoy this kind of content and you'd like to keep up to date with Crosstalk's latest videos, go ahead and hit that subscribe button down below. It's like giving us a nice warm virtual hug, and best of all, it's absolutely free. Let's start by talking about the Orange Pi 5's hardware. It's got some pretty impressive stats. The CPU is a Rockchip 8-core 64-bit processor, and it comes in flavors of 4, 8, 16, or 32 gigs of RAM. Though honestly, 32 gigs of RAM on a single board computer does seem a bit extreme to me. If you need that much RAM, you should probably just bump up to an Intel NUC or something. However, if you are aware of a great use case for a single board computer that actually requires 32 gigs of RAM, put that down in the comments below. I'd be curious to hear about that. The Orange Pi 5 also features a Mali G610 GPU, which boasts support for up to 8K video at 60 frames per second, which again, I don't see a lot of people buying this device for 8K video, but perhaps if you're using it as a media server or something like that, the extra GPU power can be useful. Beyond the CPU and GPU, it also comes with a gigabit NIC, a full-size HDMI connector, as well as that M.2 slot for either an NVMe SSD or a combo Wi-Fi Bluetooth card. Now, the Orange Pi 5 isn't the first board to come out that has an M.2 connector on it, but I really do love this feature. For my Orange Pi 5, I purchased a 128 gig M.2 NVMe drive from Amazon for less than 20 bucks. I've got links to all the products that I feature in this video down in the description below. The nice thing about the M.2 SSD is that it is much faster than microSD, as well as more reliable over time. Plus, the fact that it lives on the bottom of the board keeps everything nice and compact versus the Raspberry Pi 4, which requires like an external SSD. Now, the Raspberry Pi 4 still does have a couple advantages over the Orange Pi 5, depending on how you're using it, such as the dual HDMI connectors versus the single HDMI connector on the Orange Pi 5. But to me, the most glaring omission of the Orange Pi 5 is the lack of any wireless connectivity whatsoever. There's no built-in Wi-Fi or Bluetooth. Now, you can add Wi-Fi and Bluetooth by popping in a combo Wi-Fi and Bluetooth card into the M.2 slot, but now you don't have anywhere to put your M.2 SSD, so you kind of have to choose between wireless connectivity or onboard storage. So either way, you can always add external accessories to get everything you need, but it would be nice if the Orange Pi 5 just had a Wi-Fi chip built into it. That'd be amazing. One of the other things that I've really found challenging is the lack of online documentation as well as sort of community feedback about this board. It's brand new, right? So it's still in its infancy versus the Raspberry Pi 4, which has been around for like 3 years, and it's got tons and tons of online history of people, figuring out how to do stuff with it. The Orange Pi 5 doesn't yet even have full OS support dialed in. For example, if you go to the Orange Pi 5 official downloads page, the Orange Pi OS folder is completely empty for this board. There's also the popular Armbian OS, which did not have a page for the Orange Pi 5 just a couple of weeks ago when I first received this board. Now, though, it does have an Orange Pi 5 page, and I've been able to successfully install Armbian onto the M.2 SSD of this board and boot off it without a microSD card. So the software and support is getting there, but finding any answers about this board is, still pretty scarce. Now, in order to help combat that scarcity, I'm going to show you in this video how to install Orange Pi's flavor of Ubuntu 22.04 onto the Orange Pi 5 with a micro SD card, and then I'm going to further show you how to get everything to boot off of the M.2 SSD so that no micro SD card is needed whatsoever. To get started, you're going to need an Orange Pi 5. You're also going to need a micro SD card. I've also got some heat sinks that I've put on the board, as well as that M.2 SSD. Links to everything that I used for my own Orange Pi 5 are down in the description below. So in this video, I'm going to brush through all of these steps pretty quickly, but I do have an accompanying blog post which dives into everything into much more detail and allows you to copy and paste the Linux commands that we're going to be using. Link down in the description below. All right, to get started, we are going to first set up our micro SD card. I'm using a SanDisk Ultra 32 gigabyte micro SD card. This is a class 10 SD card. Pretty standard stuff. I'm going to pop it into my computer here. And then you want to navigate over to the Orange Pi 5 downloads page, which if you go to the product page for the Orange Pi 5, it's right here under download. Now there are a bunch of different operating system options that you can use. The official Orange Pi OS doesn't appear to be there yet, but they've got an Ubuntu image, a Debian image, an Android image, etc. We're going to do the Ubuntu image, so I'm going to click Downloads here, which brings me to this Google Drive. And then we've got a couple of different versions. We've got the desktop and server version of Focal, as well as Jammy. Now, Focal is the 20.04 version of Ubuntu, and Jammy is the 22.04 version of Ubuntu. So we're going to get the latest and greatest. I'm going to get the desktop version, which has the XFCE GUI interface. So we're going to go ahead and download that. Once you have that file downloaded, you're going to want to unzip it with something like WinRAR, and you're going to end up with a .img file. This is the image that can be flashed onto that micro SD card. So let's go ahead and do that next. To do that, we're going to use a program called Balena Etcher. Now from here, we basically pick that image file, then you pick your micro SD card, and then you click flash. And that's really all there is to it. It will now flash the card, and then when it's done, you can boot the Orange Pi 5 directly to that micro SD card. So while we're waiting for that to happen, let's go ahead and get our Orange Pi 5 all set up. So here you can see the Orange Pi 5. Now I put a bunch of heat sinks over the CPU, the RAM chips, basically any exposed chip. I went ahead and put a heat sink on. I don't know if that's overkill or not, but you know, look, better safe than sorry, right? On the bottom, we have our M.2. So the M.2, this is a 2230 size M.2. It'll also take a 2242 size M.2 using this screw hole right here. I was not able to find the appropriate M.2 securing screw. So you need one that screws through this hole. This is not threaded, so you basically have to find the right screw hardware, which I really was not able to find. If you guys know of the right kit to buy so that you can get this screw on here, it's a really thin screw. It's not the same standard M.2 screws that go on like a PC motherboard. It's smaller than that. I was able to find the actual screw, but just not the part that secures it to the other side of the board. So what did I do in that case? I just used some hot glue, right? So I took some hot glue and I popped it in there, and it seems to be holding just fine. All right, so there we have that. Now I also 3D printed this case here. I have the STL file for this 3D printed case in the blog post. I like this one a lot. It's really sturdy, plus it has a lot of ventilation. It has a space for an optional fan if you want to put a fan on it. And it also is a lot sturdier than the first case that I printed. This is sort of the second design that I've tried out. I actually like this one a lot. So we pop the board into this case like so, then we put the top on, and it snaps together without any screws or anything. And now you can see we have access to all of the ports, and we can even see our M.2 SSD through the bottom vent holes here. So now we have our board, we've got a case. The case, by the way, is optional. You don't have to have the case, but I like to have it secured into a case. And now we need to plug everything in. So here I have HDMI. There is a full-size HDMI port. I actually like the full-size HDMI port versus the Raspberry Pi, which has that mini HDMI connector. Ow. Just hit myself in the face with the audio connector. All right, so there is a spot for an 1/8" audio connector right next to the HDMI. That's optional. I've got it just plugged into this little Bluetooth speaker right here that I'm not using as Bluetooth since there's no Bluetooth on this device. but I do have the 1/8" plug plugged into the Bluetooth speaker. I'm going to plug in Ethernet. This is a gigabit Ethernet port right off the front. And then we need a keyboard and mouse. So you can use something like this, right? Whoop. This is sort of a little trackpad USB keyboard mouse. This works fine with it, but it's just kind of a pain, especially for a video like this. I like to have a full-size keyboard and mouse, and those are going to plug in like so. And right as I finish plugging all of these in, our microSD card is just about finished. So I'm gonna pull the microSD card out of my computer and then pop it into the microSD card slot on the Orange Pi 5, and we should be able to boot right into Ubuntu. All right, so the microSD card has been inserted, and now we just need to plug in power. It gets power with USB Type-C, and it's the power connector that's right up here by the 1/8" audio. Plug it in, we should see a red light pop up right about there, which allows us to know that it has power connected. There is also, by the way, a power button right here that you can use to reboot or power off or power on the device so that you don't have to keep constantly plugging and unplugging the USB-C power cord. And as we can see on the screen here, we are booting into Ubuntu, and then it's going to automatically log us into the desktop interface. Logged in, ready to go. You can change these settings though, so that it does require a username and password to log into the desktop, but by default, it just logs you right in. So the first thing that we want to do is figure out what IP address was given to this device by the DHCP server. So I'm going to come over here to Applications, and I'm going to go to Terminal Emulator. And I know this is going to be very hard to see, but I'm doing IPA, and this is going to show me 192.168.200.158. So what we're going to do next is connect to this computer remotely through my laptop so that I can actually record the screen and show you guys what I'm doing. Okay, so from my laptop, I have used PuTTY to connect to this IP address, 192.168.200.158. Yours is going to be a different IP address than mine, so make sure you get the correct IP. And we're going to log in as root with the default password of Orange Pi, all one word. There we go, we've logged in, and we can see right here, it says General System Configuration, Orange Pi-config. So let's go ahead and run that and take a quick look around. This Orange Pi configuration utility gives us the ability to change a lot of things about the system itself, or the network, or for instance, the time zone, if I want to select a specific time zone. For me, I am in America, Los Angeles. There we go. This is also where you can set settings like whether or not you're automatically logging into SSH when it boots up, whether or not you're automatically logging into the GUI when it boots up. All of that can be determined through this configuration interface. For now, though, we're going to go ahead and exit. And let's just run updates for the system. So we're going to say sudo apt update and sudo apt upgrade -y. This is a relatively new release, so I don't expect that there will be a lot of updates. This should just take a minute, but if you're watching this, further in the future, you might have more updates than I have here. Okay, so there we go. Now, if you want to just run off of the microSD card, you're done at this point, right? You've got a full system up to date. You've got the GUI of Ubuntu and everything's ready to rock and roll. But we want to be booting off of the M.2 SSD instead. Before we do that though, let's take a closer look at the different drives that are in play here, right? So we know we have the microSD card. That's going to be one of our drives. We know that we have the M.2 SSD. That's going to be another drive. And then we also have on board the Orange Pi 5 is what's called an SPI flash drive. So it's a 16 megabyte SPI flash. And that SPI flash is basically the way to say, hey, I'm gonna boot over here or I'm gonna boot over there. And we can make changes to that SPI flash so that right now it's by default booting to the microSD card. We need to tell that SPI flash, hey, no, boot to the M.2 instead. And there is a real simple way to do that. But if you're like me, and you've been messing around with the Orange Pi 5 a lot, every time you make a change or put in a new operating system, you basically need to clear out that 16 megabyte SPI flash so that you can reuse it. It won't overwrite. So you have to basically completely clear out all the partitions and then run the steps necessary to tell that SPI flash to boot off the M.2. So what we're going to do here is optional. This is only if you've already put stuff on the M.2 or put stuff on that SPI flash. then you're going to want to run these commands. I mean, it's not going to hurt if you run them anyways, but these are the steps to basically reinstall the operating system onto the M.2. First thing we want to do is sudo fdisk-l. And for all of you naysayers out there, I know that I am logged in as root, so I don't actually have to use sudo for these commands, but it's just force of habit, and don't be so critical. Here are a few drives that we see in fdisk. We have MDT block 0, 16 megabytes. This is the SPI flash drive. And notice that the SPI flash drive right now has 7 partitions on it. If you are setting this up for the first time, I think you'll have 0 partitions. I think it'll be completely empty. Then scrolling down a little bit further, we have NVMe drive. So this is the /dev/NVMe0N1. This is my 128 gig NVMe that I've got strapped to the bottom of the Orange Pi 5. And then if we scroll down even further, we've got /dev/MMCBLK1. This is the microSD card. So the first thing that I want to do is I want to clear out all of the existing partitions on both the SPI flash as well as the M.2 SSD. So let's do that right now. I'm going to say sudo gdisk/dev/mtd block 0. Okay, so if I hit P, this is going to show me all 7 of those partitions. P means print out the existing partitions. And I just want to delete them one by one. So I'm going to say D for delete, and then we're going to do 1. Then we're going to D for delete, and we're going to do 2, and so on and so forth until we get all of these deleted. Okay, so now if I hit P, we've got nothing. I want to hit W, which is going to write these changes, and yes. And now let's do the same thing for the NVMe. So we're going to do sudo gdisk/dev/NVMe0N1. If I hit P, we can see that it currently has 2 partitions on it, 1 boot partition and 1 that's just the rest of the space on that M.2. So we're going to say D1, D, and now those are both gone if we hit P. So let's write those changes as well. Again, if I'm going too fast here, full instructions are in the blog post. Follow along with the blog post at your own speed. I've cleared out the partitions. We are basically now ready to image an operating system onto that M.2 as well as tell the SPI flash to boot off of that M.2 drive. But I don't have the image on here yet. So like if you guys remember, I downloaded that image from the internet, and then I flashed that image onto the microSD card. We essentially need to do that same thing, but this time we're going to flash that image onto the M.2 SSD. So to do that, we're going to use Windows PowerShell, but you can actually copy it over any way that you can actually get it onto the device, right? So like if you want to just put it on like a USB thumb drive and then, bring that over here and plug it in and then copy it off of the USB thumb drive, however you want to do it is totally fine. The point is you need to get that image file over to the Orange Pi 5. Okay, so in Windows PowerShell, I've put myself into the directory where that image file lives. And if I do a dir, we can see that I've got the around 8 gigabyte image file. I'm going to use SCP. We're going to say SCP, which is Secure Copy or Secure Copy Protocol. And then I'm going to hit O tab, right? And that's going to fill out the rest of the file name for the image file. Space. So that's the source, right? I'm copying from this source, this image file. I want to copy it over to the destination, and the destination is going to be root at, and then the IP address of the Orange Pi 5, which is 192.168.200.158 in my case. Your case is going to be different. 192.168.200.158 colon, and now we need to put the directory or file location where we need to store that file. So I'm going to put it in /home/orangepi/downloads. Hit enter. It should ask if we want to connect. We're going to say yes. And then it's going to ask us for our root password, which remember by default is Orange Pi, all one word. Enter. And now that image file is copying from my laptop over to the /home/orangepi/downloads folder on the microSD card that it booted up to originally. All right, so we're going to let that copy, and then we will come back when it's done, and we will flash the M.2 SSD. Our image file has now been copied over to the microSD card that is currently running the Ubuntu OS on our Orange Pi 5. It is now time to prepare that SPI flash drive, the 16 megabyte SPI flash drive. And to do that, we're going to go back into Orange Pi config. Once in Orange Pi config, go to System, and then Install. And then we want to come down here to option 7, which is install update the bootloader on SPI flash, and click OK, followed by yes. Now, if your SPI flash has already been used, like if it's full and pre-partitioned, you're going to get an error when you say yes here. It'll say something about not enough space on the SPI flash drive. If that's the case, you got to go back to earlier in this video when I deleted out all of the partitions and go do that step first. For now though, we're going to let this run. It'll take about 5 or 6 minutes for this process to finish. Once that's completed, you're going to get kicked right back out to the system settings, so we can say back and exit. And the next thing that we need to do is actually flash our image, our operating system image, over to the M.2 SSD. And to do that, there is a big long command that we need to copy and paste. So let me go grab that. All right, here you can see it on my screen, and this is a command that I don't have memorized. This is actually why I document everything in blog posts, is really for my own benefit, right? So that I can go back at some point in the future and say, you know, how did I do that again? Oh yeah, here it is. So we're gonna take this command. First, we need to be in the folder where we copied that image file. So I copied it to home Orange Pi downloads. So we'll say cd home Orange Pi downloads. And if we look in here, we can see a 7.7 gigabyte file. So we're going to say sudo ddbs equals 1m, and then we can just say if equals o and hit tab, and tab is going to autocomplete the rest of that file name for us, so we don't have to worry about it. Then we're going to say of equals, this is the destination where we are flashing that image file or copying that image file, /dev/nvme 0 and 1, and then we're going to say status equals progress. Now this is where you're going to press enter, and it's going to take about 2 minutes for this command to flash that image file over to the micro SD card that is running on the Orange Pi 5. However, due to the magic of editing and the magic of YouTube movie making, I have actually done this already in the past. This is the second time I'm recording this particular segment of this video, because the last time I recorded it, my dog walked underneath my desk and pulled the power plug on my main camera, so I lost all of that footage. I'm not going to run the command here because of that. I have already flashed it across. If I was running the command, however, I would tell you while it's flashing that this is the same process that you're going to use for almost every operating system that you want to put on that M.2 SSD. In fact, I use the exact same process to put Armbian on here instead of Ubuntu, and it worked perfectly fine. I was able to boot off of the Armbian image just like I am booting off the Ubuntu image here. So we're going to say shutdown-h now. And that is going to shut down our Orange Pi 5. Now that it's shut down, I'm going to pull out the micro SD card, and then we're going to hit the power button to power it right back up. And what you'll notice here is that it should boot significantly faster than it did previously. There we go. We are now back into the Ubuntu desktop in probably about 10 seconds from when I hit that power button. One other thing that you need to know. If you want to reuse the micro SD card in the Orange Pi 5, the data volume of this micro SD card has the same UUID or unique identifier as the data volume on the M.2 SSD. So there's a command that you can run that will overwrite and randomize the UUID on this micro SD card so that you can use them both together. Otherwise, if I put this micro SD card back in and I reboot, it's going to boot right back to this micro SD card because the UUID matches and it takes precedent over the M.2 SSD. So you want to change the UUID if you're going to keep using the micro SD card. I'm not going to put instructions for how to do that in this video, but the blog post has full instructions on how that is done. All right, so back in the Orange Pi, this is now running off of our M.2 SSD. So it's essentially a completely brand new version of the operating system, right? So if I say IPA in a terminal emulator, the IP address has changed. We're now 192.168.200.159. So when we reconnect, you want to reconnect to the new IP address This also means that any configuration changes that you had done while you were booting off the microSD card, such as setting the time zone or setting any other settings in Orange Pi config, those are all going to have to be redone on this new operating system. But everything is working great. Let's go ahead and pull up our web browser and go to YouTube. And here we can see that the video is playing very nicely because of the GPU and the power of the CPU of this Orange Pi 5. And actually, I'm wearing the exact same shirt in this video that I'm wearing right now, so it's like YouTube Inception or something. Now remember also that I had plugged in an audio cable that I have plugged into this little Bluetooth box right here. Let me turn it on. 100 megabits download, 8 to 25 megabits upload. Priority residential is 20. And then here you can see that I also now have audio coming out of YouTube as well. Let me mute that again. All right, now you can see that I also have audio coming out of YouTube as well. Everything is working perfectly fine. You can use Bluetooth, again, if you put in that wireless Wi-Fi and Bluetooth chip instead of the M.2. Okay, so I have now reconnected back into the Orange Pi 5, and we're going to, let me actually stop this so I'm not messing with any of my benchmarks. We're gonna run an SSD benchmark that will show us just how fast this M.2 SSD is in comparison to the microSD card. So if you go back to the blog post, there's a command that you can copy and paste right here from pibenchmarks.com. This is a great little application. What this command does is it goes out and it installs all of the files that you need to run the benchmark, then it runs the benchmark, then it asks you for a description as well as your alias. And you don't have to put in an alias, you can be anonymous if you want, but if you do put in an alias, it stores all of your benchmarks so that you can look them up in the future and see what past benchmarks you have run. So right now it looks like it's running some of those tests and then it's going to ask us for some information. So for description, I'm just going to say Orange Pi 5 Ubuntu 2204 M.2 SSD for YouTube. And then for alias, I'm going to say Crosstalk Solutions. All right, so the score that we got is really good. Look at that, 19,924. Let's go on and head over to pibenchmarks.com and see how that score stacks up. So if we come over here to fastest SSDs, the absolute fastest one is 24,307. Our score of 19.9 puts us in about 6th place as far as fastest average benchmarks for our particular SSD. That's really, really good. Now, if we look at the fastest benchmarks for SD cards, we're coming in at just over 2,000, a score of just over 2,000. So SD card was about 2,000. Our M.2 SSD had a benchmark score of 19,900. So you can see that it is significantly faster to run off of an M.2 SSD for all of your single board computing needs. And now here we can see my test has just popped up as the latest test result, and we have our score of 19,924, running this Kiozia OEM PCI NVMe SSD on an Orange Pi 5. All right, so there you have it. Links to everything that I used in this video down in the description below, including a link to the blog post that gives you those full-on step-by-step instructions for how to do exactly what I just did. And if you're looking to keep this party going, click over here on the right for one of these videos that I have handpicked for you to watch next. The one on top is my very world-famous Getting Started with Raspberry Pi 4 video, and right below that we have a video on the latest LastPass breach, which is important information for anyone using LastPass. All right, we'll see you guys in the next video.